Hi Mr. Lee, welcome to my presentation video for the results part of this assignment. In this video, I'll be introducing my design of the elevator system and demonstrating it. So firstly, as what is mentioned in the report, I've chosen ports 1 and 2 as the input ports for outside and inside the elevator respectively, with port 0 as the output port. While for port 3, pin 3.5 is used as the input for the SOS button inside the lift. These are the ISR for the external interrupts 0, 1, and timer interrupt 1. In the main program, I've set ports 1 and 2 as the input ports and port 0 as the output port. I've also initialized the initial lift position to be at ground floor. Then, the timers and the external interrupts are enabled. In the T-mode register, the CT bit is set for timer 1, which means that timer 1 is programmed into a counter and timer 0 is set to operate in mode 2 as well as for counter 1. Then, the high and low bytes for TH and TR registers for counter 1 and timer 0 are loaded with values. For counter 1, TH and TR are loaded to become FFFFH. It is done in this way so that a pulse from the external hardware increases the TH and TR registers by 1, so it rolls over and sets the timer flag. When the timer flag is set, the timer interrupt 1 will be triggered to execute its ISR, and this is implemented on the SOS button. Therefore, when the SOS button is pressed, this acts as the pulse that increments the TH and TL, so the ISR for timer interrupt 1 will be executed until another button is pressed. The timer interrupt 1 is set to have the highest priority in the IP register as it is the emergency button, then followed by external interrupt 0 and 1. Then, this is to enable the power saving mode in the microcontroller, and here creates a loop so that the microcontroller enters the idle mode every time after executing the ISR. Now, I'm going to demonstrate my program. When the program is run, it can be seen that the lift is now at ground floor as this is set in my main program. When there's an input outside the lift, for example down input from second floor, the lift will move from ground floor followed by first floor, then it reaches second floor, and the door will be opened to fetch the passenger in and close. So now, I trigger external interrupt 0 and I input down from second floor. The third bit of port 0 indicates that the door is now open. The delay is made a little bit longer to avoid any accidents to happen for real-life applications. Next, when there is an input inside the lift, for example ground floor, the lift will move from second floor followed by first floor, then it reaches ground floor, and the door will be opened to let the passenger out and closed. So now, I trigger external interrupt 1 and I input ground floor. The door is now open to let the passenger out. For the situation when there's a person inside the lift who wants to go to second floor from ground floor, and there's another person at first floor outside the lift who inputs up to go to second floor too, the lift will move from ground floor to first floor and opens the door to let the passenger in and closes it. Then, it will continue moving up to second floor and opens the door to let both the passengers out and closes it. So now, I trigger external interrupt 1 and I input second floor, and then I immediately input up from first floor. The lift stops at first floor to open its door to fetch the passenger in. Then it continues moving up and opens its door to let both the passengers out. Moreover, a person inside the lift can control the opening and closing of the door. When the first pin of port 1 is pressed, the elevator opens its door, while when the second pin of port 1 is pressed, the elevator closes initializes its door, and this can be shown by the third bit of port 0. When it is off, it indicates that the door is open, while when it is on, it indicates that the door is closed. So now, I trigger external interrupt 1 and I input open door. Then, I input close door. When a person inside the lift wants to stop the lift immediately in case of emergency by pressing the SOS button, the lift will stop at where exit and the LEDs will blink, which indicates that the lift is now in the SOS state. These blinking LEDs indicate that the lift is now in the SOS state. To stop it, the Stop SOS button is pressed, and the LEDs will stop blinking, and the position of the lift where the SOS button is pressed will be displayed. By now, the system is ready for any of the inputs again. That's all from me. Thank you.